Yes, once again, I'm back. This time I'm just demonstrating to you the same bridge, foundation truncated, and we have introduced the pile. Pile foundation, assuming that the soil demands use of pile as as investigated by geotechnical team. This pile, I assume the length about 20 meters, diameter about 0.8 meters, and then connected onto the vertical abutment. So basically, that is how the whole thing is. If normally, if without that, you could actually have a look at it like this. Yeah. So if you follow the principles of dealing with piling, you know the edge distance, you know the center distance, spacing. So from the center line of this pile to the end should be about maybe 1.25 or 1.22 depending on which code you're using. And then if you have like this, the center line could be between here and the edge about 1.25 or 1.22 or 1 normally as minimum. Then the spacing between these piles should be at least 2.5 or 2.2. Most literatures have some varying degrees of, but you have to look at that. Then if we are dealing with if you find that the pressure bags are overlapping and then creating a bit of deformation unnecessarily, then you can also adjust. But these are small river bridges that we are dealing with. In this case, I'm just interested in looking because the joints are the same. This is a rigid connection, and then what I'm trying to look at is how the load is transferred downwards, and you can see the response of piling to this kind of arrangement. So basically, that is how our pile foundation looks like, and that is the moment due to dead load. But normally if I do my combination load, which I think after modeling you would have done, this is it's about 490 kiloton meter at the joint between the vertical wall and where your pile starts. Then for the moment, no, for shear forces, these are your shear forces are. Now this pile you simulate it using spring constant in the X, Y, and Z direction. Then at the bottom, I assume that it is end bearing, so it is combined. You have both friction and end bearing. Now there are other accurate softwares that normally designers use, which I think SoilWorks and others. You can easily get to know the deformation and then get to know other graphical representation which is not captured by the Midas team. So here I am able to see shear, I'm able to look at moment, and then I'm able to look at the axial loads. Yeah, basically that's what you should be able to look at. Then for plate forces, I can actually go to the plate forces, look at the moment. That is how the moment would look like. And if I want to see the sections that I've already cut, then I should be able to have a look at that. So this would be my plate forces, and then that is for moment, and this is for shear volume. Basically, that's how you would look at that. And then if I want to know the forces in the pipe, you already seen that. This one, I think I did not consider earthquake, so we are able only to look at the soil effect. Let's have a look at the lateral soil effect on your this is how it will look like. But if I take it down to our piles, how would it also look like? So basically, so you can see that. What about temperature? We normally neglect temperature in our design, but have a look at what temperature temperature can do. You can see you apply temperature up in the slab, on the slab, but it has implication down here. So basically that is what you need to do, that once it's rigid and you have piling, you have to take note of all this, and then if you go along and do your design, you should be able to have a look at the pile foundation, which I could quickly show you here what I did out of that. Where is my piling? Oh, pile foundation, design of abutment. I think I might have pile design is here. Okay, so this is how, once you do your design, you go and specify pile diameter, your reinforcement required, because all the loading you have already applied, you have modeled, you have put boundary conditions, you should be able to have something like this. So you can load it. It gives you all, this is your PM interactions, the actual and moment forces, applied forces. Here I consider about 62, but you can still refine for economy. So this is what normally what you need to do. Thank you. That is what we can do quickly, and I think what more would I need to show you is maybe a deformation. I'm always very much in love with deformation, and then I want to see how the whole structure behaves. This is temperature effect, by the way, and if I animate that for you as my last step, then you should be able to see. And what about if it is deformed? So that is, you can now see the behavior. Look at how this, of course, is exaggerated. But look at how when you have a rigid connection, the most dangerous location when you have pile is at the pile cap and pile interface. You have to be careful at that. That's where you have the maximum moment, the maximum shear force. You have to make sure it's properly detailed, proper sizing, proper stiffness. Very important. Thank you so much.